one problem that Jack sent me. Anyone else want to send me a problem to do? That's fine. If you don't have other problems you want me to go over, then we'll just go right into the mock test. So the problem I have here, Jack, and tell me if I'm right because it's all sideways. I've got f of x is equal to square root of 1 minus x squared times the arc cosine, is that right, of x? And so we remember if y equals arc cosine of x, y prime is negative 1 over square roots of 1 minus x squared. So, right, I'm not giving you a problem with arc secant or arc cosecant or arc cotangent, just tangent, sine, and cosine, right? Inverse of each of those. So on this one, I need a product rule. First function in the product is square roots of 1 minus x squared. Derivative is negative 2x over 2 square roots of 1 minus x squared. You know, hopefully you're doing this chain rule so often that you can kind of, you know, skip that some of the process, but if you can't, that's fine. And then my second function is the arc cosine of x, and of course the derivative is on our formula sheet, right? So this is my loop. So it looks like what do I have? I'm going to use, it doesn't matter which product I use first, but so negative square roots of 1 minus x squared over square roots of 1 minus x squared. And then I have what? Minus x arc cosine of x over square roots of 1 minus x squared. Of course, this is just 1. I would imagine that this is the answer they have in the book. But I want you to remember, I want you to give me a single fraction completely factored. Every time you give me a derivative, whether I tell you or not, I want a single fraction, factored numerator, factored denominator, right? So if you need to add that to your formula sheet, that's what I want, do it. If you need to add to your formula sheet that I want a y equals mx plus b for a tangent line, do it, right? If you can't just remember those things, you want to keep note of the things I'm asking you to do. Jack, where was the problem on this one for you? This one I didn't need a triangle. So I guess you could have said that, my second function here, so this could have been what? F times g, right? Right? So you could have said, well, g is the arc cos of x, so cosine of g is x, but you didn't need it. It's just the same thing about learning what is a truck, a car or a truck. No one told you. You do enough, you see enough of them, you'll eventually know. Same thing with a cat and a dog. Oh, look at that ugly dog with no hair. No, that's a, what kind of cat is that again? With the one with no hair? Looks like Yoda. A sphinx, maybe? Yeah. Jack, you sent me a second one? So are you okay on the first one here? Okay. Okay. Yeah, so again, I think I need a triangle on this one. It's just a gut thought, though. Yeah. To what? Yeah, but that was just me thinking about, did I need a triangle? But I didn't. This next one, I think I need a triangle. So this is y equals a square of the inverse tangent of 8x. So I certainly see this as y equals theta squared, right? So that might help when I'm thinking about this problem. Certainly theta is the inverse tan of 8x. So tangent of theta is 8x. So I have a triangle, right? A right triangle with an angle of theta, and I have an 8x and a 1. And so my other side is going to be square root of 1 plus 64x squared. Right? I'm just doing Pythagorean theorem there, right? A squared plus b squared, right? I don't know if I need it, right? I'm not quite sure if I need it. And I would have worked on the other problem the same way. I see an inverse trig, but I'm not quite sure if I need the triangle. But once I started creating the triangle on the other one, it didn't make any sense at all. At least I've not seen, right, me use something like this to create a triangle yet. Yes. Yeah, if you can give me, so I could ask you just for the derivative, and if I don't say in terms of x, I'm not going to mark you wrong. But on your test coming up, I'm going to say solve this give me y prime in terms of x. So that means I don't want a trig in there, I don't want an inverse trig in there, etc. So anyway, let's go with y prime now, right? So y prime is what? 2 times theta prime, right? So that is what? 2 times the arctan of 8x times the derivative of the arctan. How do I do the derivative of the arctan? I find u prime, I find u squared, right? And so now I'm putting that in. 2 times the arctan of 8x times 8 over 1 plus 64 x squared. And guess what? I don't need the triangle here. I wouldn't ask you for it. Arctan of 8x or inverse tan of 8x, it doesn't matter, either one. Because what could I possibly replace with that? Theta, right? That is theta. So I can't write this one in terms of x. I guess arctan of 8x is as good as I can for in terms of x. But you'll see, the first one we do today, I'll need the triangle. I'll be able to solve it in terms of x. Go ahead, Jack. One more time. Louder. Yeah. Okay. So sometimes you can't solve in terms of x. When I want it that way, I will tell you, okay? Yeah, but this one is just nasty. Just the algebra is nasty on this one. And I think we did this in class, didn't we? So inverse tan of x minus square roots of 1 plus x squared. So the algebra is just hideous. You're going to need a conjugate. It's just horrible. But anyway, we have this memorized. Y equals the inverse tan of u gives me y prime is u prime over 1 plus u squared. So all I have to do on these is find u. What is it? X minus square roots of 1 plus x squared. Find u prime. Yuck. What is it? 1 minus 2x over 2 square roots of 1 plus x squared. And if I get that to a single fraction, I get square root of 1 plus x squared minus x all over square root of 1 plus x squared. You can kind of see where my conjugate's going to come from there, right? And then u squared is what? X minus square roots of 1 plus x squared, quantity squared. Again, yuck. Horrible algebra on this one. You're going to need a conjugate. You're going to need to distribute. It's really messy and easy to make a mistake, right? So what do I get now for y prime? I get all of this. That's my u prime over 1 plus this, right? This quantity squared. Yeah. Yep. I got solutions to everybody except for Chris and DeWitt, correct? Quiz solutions. Robert, please, what's up? One more time? Yeah, we're going to do them together. I'm going to give you 10 minutes, then I'll do the solution. Yeah. All right. So Jack, you want me to do this algebra? Thank you. I appreciate it. So it's just a mess. Be patient. Cheat. Look at the answer. The answer in the book, you'll be surprised what the answer is. It's like 1 over the square root of 1 plus x squared or something ridiculous like that. So, but you got to say, okay, I know the answer. How am I going to get rid of some of this stuff? And I've already told you, you're going to use a conjugate. You're going to have to distribute this horrible expansion thing, right? But it should work out. And when you get it, it's going to be like putting that last piece in the jigsaw puzzles that you worked on all week. You know what I mean? Anybody ever do puzzles like that? I always steal a piece, so I'm always the person that puts the last piece in. Oh yeah, I'm evil. Yeah. Okay, here we go. Mock test. Yes. We ready? Okay, number 1, 10 minutes. And I got a funny joke here. This is Mach 1. That just cracks me up. I'm sorry. So I'm doing the cotangent of x minus y equals x squared. And notice I said, find me the solution in terms of x, right? 10 minutes. So I think it's a good thing for you to have your formula sheet going so that if you realize you need to add something. Sorry, minus cosecant squared. Three minutes. You want to be doing this like it's your test. You're not copying me, right? Do it like it's your exam. a trig already, so we can go to a triangle. Don't know if I need it, right? So wait, just the trig, cotangent, right? So adjacent over hypotenuse, yes? Okay, and I get the other side by Pythagorean theorem. Did anyone get the triangle? Nice. If you didn't get the triangle, why? I don't know why. So, because you're going to have to find a triangle for sure on the test. You're going to have to do it in Calc 2. So you've got to be able to do these. I take the derivative of both sides. Derivative of cotangent is negative cosecant squared. And then the derivative of the inside is 1 minus y prime. And the derivative of the right side is 2x. Anybody get that? Okay, good. And if you didn't, why? Tell me, I want to understand why, right? Maybe you don't have the cotangent derivative on your formula sheet. I don't know. Make sure they're all on there, right? So now I'm solving for y prime, right? Dividing by cosecant squared, solving for positive y prime. Once I get here, I'm going back to my triangle. Anybody get this piece right here? You could have still had it over cosecant squared. That's fine, because it's still going to give you the same result once you go back to the triangle. So there's my sine, and there's my sine squared. And then I'm getting an LCD. Remember, every time you give me a derivative, I want it as a single fraction, completely factored. If you got me this double red box, I'd be fine with that. I would like you to graph things to see if you can see a root, right? And so if I graph that, x to the fourth minus 2x plus 1, right? I definitely see a root. Oh, what did I do? Plus 2x plus 1, sorry. Plus 2x plus 1. I definitely see a root at negative 1. And so that prompted me to do synthetic division, right? With, you see it? 1x to the fourth, 0x cubed, 0x squared, 2x plus 1, right? And so that I got a factor of x plus 1 in this piece. I then graphed that new piece. If so, yeah. You did it in pre-cal. It's finding roots and then reducing a polynomial. You didn't know about it? Anybody remember synthetic division from pre-cal? Two of, say, 18 is not bad. 3, Matthew, yes? Yes. That's from the triangle. So I'm looking at my triangle for the sine ratio, right? The sine ratio is here. So I take that ratio and square it, and that replaces sine squared. Say again? Oh, it's the angle from the triangle. I called it alpha. So if you got there, I'd be pretty happy if you got to this extra synthetic. That's super, right? If you got to that extra factoring. Obviously, this piece is not as simple as this piece, right? But from what we're doing in chapter 4 is we want to be able to find these critical values, right? So I've been stressing this all along so that you can get ready to give me critical values, right? We did some of those Monday. Okay, good. Let's go to Mach 2. And I want you to solve this one by first taking the natural log of both sides. And we're using the properties of the natural log from pre-calc class before we take our derivative. So let's go another 8 minutes. No, maybe 10 minutes. Still 4 minutes left. Once time's up, almost 1 more minute. One minute. Anybody get there? Nice. Nice. Yes, Petra, nice. Yeah. No, it's okay. Make sure you do them over, right? All right, here we go. Time's up. 12 seconds actually, but who cares? Let's talk through it first. And as I go, you're not copying because it's not going to help you. Do it over yourself. I take the ln of both sides. If I tell you to take the natural log of both sides, that means I want you to do it that way. If I don't tell you, I say just find me y prime, you can do it using the product rule, quotient rule, or this natural log trick, right? This particular problem. You could do it any of those three ways. Most likely I will tell you, okay? So I take the ln of both sides, and from pre-cal, we know that the log of a times b is the log of a plus the log of b, right? So that's how I get line 3. And we also know from pre-cal the log of a to the n is n times log of a. So that's how we get line 4. Everybody with me there? You remember those properties of logs in pre-cal? Anybody remember the properties? Oh, that's good. Then I take the derivative of both sides, and remember the derivative of ln is very simple, right? D dx of ln of u is u prime over u. So it's real simple the way we gave you that formula, which kind of hides the chain rule. So derivative of the inside is -2, right? Sorry. Derivative of the inside is -2 over the inside. Done. Derivative of the inside is 1 minus 2x over the inside. And then I cross multiply because I'm solving for y prime, so I'm going to cross multiply to get y on the other side. And I know I can also factor out a 2 here, right? I see a 2 here and a 2 here. I can factor out that 2. So I get 2y times this leftover piece, and I'm going to get an LCD in there, right? You see that? So I'm just simplifying things, and then I'm going to get an LCD in step 9. Once I do that, I can factor things out and they combine, and then I'm looking at this piece, trying to simplify that as much as I can, and I get to here. I get to this box solution. So, and you can see I wrote myself a note. I better check and see if this factors. In fact, I should check and see if this factors as well, right? It turns out that that first piece does give me 2 real roots or 2 critical values, and the second piece does not factor at all. And how can I tell that? Looking at that second piece, you can see it doesn't hit the x-axis, right? Matthew, question? Why is the original problem? Yep, right there. Yep. So if I had told you do it by product rule or quotient rule, you would have never lost that y to begin with. So you can always double check for yourself when you're doing one with an ln. See if you can do it with a product rule or quotient rule and double check that you get the same answer. Do it. Say again? Oh yeah, picture. Let's see how many we got here. There's the first picture. Yes? Got it? Second picture. Yep. And then last. Yep. All right, cool. Let's do number 3. Mach 3. We need a triangle on this. If I don't tell you, I still want you to give me one. If I don't tell you, simplify your derivative, I still want you to. If I don't tell you y equals mx plus b, I still want it, right? So this one, it should be obvious that you need a triangle here. Let's go 10 minutes. You're not copying me, damn it. Do your own work. And then we'll talk about it at the end. Nope, nope, secant tangent. Secant tangent. Make sure you check your formula sheet, okay? And you're not copying me. Yeah, so theta, the inside is arctan of 2x over 3. So theta prime will be the derivative of arctan of 2x over 3. And we know the derivative of arctan of u is u prime over 1 plus u squared. You with me? Yep. Still 5 minutes. Yeah. Uh, so 2x over 3 all squared is 4x squared over 9. So that's 1 plus u squared there. Uh, no, I find u prime, I find u squared. Two minutes left. Say again. No, no. You're thinking why? Because of the 2x over 3? Yeah, so y prime is
It's already there.
yes,
Oh, good.
yes, yes. Nice, 20 seconds left. Good enough. Who got there? It's a question? We don't care so much anymore, and um, the whole thing about like if I have this and I rationalize it and I get this over this, you see I have a repeated critical, and we'd like to not have to repeat. So when I rationalize that, I get a critical from upstairs of 2, and I get a critical from downstairs of 2, and I'd rather just get that critical once. So we don't, even as going forward, typically we won't rationalize anymore. If it's a number, I sometimes prefer to rationalize. See on the quiz solutions, I did not rationalize the slope or the p-value. So I'll be lenient there. But if you look at this one's rationalized, right? Right? But how many more strokes? 1, 2, 3, 4, 5, 6. 6 extra strokes than this one. I'm trying to be, in a computer science sense, as concise as possible. Now, there is no critical value from either of these, right? But again, we're saying, hey, can you write it? Can you say as much as you can with as little writing as possible? Who got there? Let me see. 1, 2, 3, 4, 5, 6. Nice. Yes. Hoy, where are you? What line? Yeah. So line 4. This piece here, right? Oh, the next one. Yeah. So I just did some algebra. so I just doing some arithmetic, really. 2 times 2 is 4, right? 3 times 3 is 9, but that's over 9, so those cancel, right? So I still have this 3 in the denominator. this piece right here, from this to this, is where did I do it? Over here, right? Some radical over its argument, right? Rad over rad times rad, one of the square roots cancel. Right? Nice. Nice. So we're looking at our next problem here. Where did I put it? There it is. So that was Mach 3. This is Mach 4. Nice. Let's do Mach 4. Let's do 6 minutes on this one. 2 minutes. All right, how we do? Anybody get there? Nice, nice. Yeah, where are we having trouble if we're not getting there? We get the y value, correct? We get the y value of 1/5. How many? Y value of 1/5. Nice. It's got to be where the derivative is then, right? It's got to be the derivative with the chain rule where you're having trouble. So I'm doing a quotient loop, right? So I finally get my derivative. And then I get my slope by plugging in 3, right? So is the derivative the issue? Is that fair to say? The derivative is where you had trouble? And if you're not using that loop, if you're not using that loop, maybe you want to use that loop. If your algebra is getting messy, if your paper's getting crowded, that type of thing. On your test, right, I'm thinking anywhere from 6 to 10 problems. Backside of every page is blank. I'll put a couple of blank pages at the end of the test, right? Formula sheet on one page, front and back, not 2 pages, not 3 pages, 1 page, right? Get that done before Friday. Nice, let's do 5. Let's do, how much time we have? Oh, we have 15 minutes. Let's do 10 minutes on 5. And then the other one, you know how to do already, so you can try that on your own. Number 6, you can try on your own. So Mach 5. 2 minutes. Anybody get there? First one at least? Yeah, nice. All right. I don't care so much for the second one at this point because clearly I can find these criticals without thinking about it. Plus my square root of 3, right? It's 0, right? So why are they important to me for the second derivative? Take a look at my curve. I plotted the 3, put down the critical minus square root of 3, 0 plus square root of 3, and then I put them into the function, found height. And now imagine I'm driving on this road. So we're in a helicopter out here looking onto the ground, right? And you're watching someone drive. Which way am I turning my steering wheel here? To the right, and then left, and then right, and then. So these inflection points, that's what they're called, is where I'm changing my concavity, changing the steering of the steering wheel. All right, good work today. I'll post this video. Have a great day. See you Friday for the test.